Okay, so in this lesson, I'm just going to talk about the general form of the wave function, right? So, as we said before, the wave function just describes two cos or sine graphs or variations of added together, right? We've actually already got these trig expressions that account for when you have sine graphs, sine functions and cos functions added together, right? They can be simplified into this form, okay? Um, but what we do in the wave function is we add in another component called k, which allows for the amplitude. So it's easiest just to show this with an example, okay? So I'm going to take the expression of a cos x plus b sine x, right? That's the same as we saw in the last slide with the 3 cos x plus 2 sine x, whatever it was. Okay, and we're saying, right, that this can be simplified into down to this form. K cos x minus alpha, where alpha is just some angle, okay? So where do we get this from? Well, basically we just get it from the expansion of these functions, and you actually get a mark for doing the expansion. So I'll show you. So for this expansion here, what's it going to look like? It's going to look like k cos x minus alpha is equal to k cos x cos alpha plus, because remember this changes, it's the other way around for cos, plus sine x sine alpha. Cool. And then you need to multiply the k through. So this then becomes k cos x cos alpha plus k sine x sine alpha. Okay, so you get a mark for doing that. But what we need to do now, okay, is to get this here into this simple form, we need to think about our coefficients, okay? So we need to think about what the coefficients of cos x are, so highlight that, and sine x, okay? We need to think about what a and b are going to be equal to. Well, we can see here that for cos x, right, cos x, the coefficient around it is this k cos alpha, right? The same for sine x. Is this k sine alpha, right? So what you can do is you substitute these out. So you're left. So if you want to know what you know that the coefficient for this cos is k cos alpha, and the coefficient here is a, you know that they must be equal to each other, right? Because if that's the coefficient there and this is the coefficient elsewhere, then you know they must be equal to each other. So k cos alpha is equal to a. What about for this one? Well, k sine alpha is equal to b, right? And this, you need to be this is like a really important part as well, because when it's written out the other way with sine, you just need to make sure you know which one we're doing. We'll do an example of that later, but you just need to be really careful because this part's really important. Okay, so now we want to know what k is, okay? We want to figure out what this k component is here. Okay, so how are we going to figure that out? Well, we've got these two expressions here. Is there any way we think we could simplify these together? Well, maybe we can use some rules. So let's just have a think about this. If we say a plus b squared is, what's that going to be equal to? Well, it's going to be equal to k cos alpha squared plus k sine alpha squared. Okay, next step, you can take the k's out, so that becomes k squared, it's a common factor, and then cos alpha squared plus sine alpha squared, right? And then you should remember that cos squared plus sine squared is equal to 1. Okay, this is another trig rule that you need to know. Okay, it's not written down in the equation sheet. This is something you're expected to know. Trig identity. Okay, so that leaves you with k squared equals a squared plus b squared. Okay, which then simplifies down to k is equal to the square root of a squared plus b squared. So now we have an expression for k. Cool. So what else do we need? We've got k. We need to figure out what this alpha is going to be, right? Well, how do we figure that out? Okay, so we have an expression for cos. We have an expression for sine. How do we figure out what alpha is going to be? Well, you should remember that tan is equal to sine over cos, right? So this is sine x, this is cos x, right? So therefore it stands to reason that tan alpha is equal to k cos alpha all over k sine alpha, right? And we also know that these two expressions are equal to a and b. So this just then becomes, I've actually written that the wrong way around. How awful. Sine and cos. And we know that cos alpha is equal to a, right? And then we know that sine alpha is equal to b, right? So this becomes b over a, right? Then we can figure out alpha, because alpha just becomes tan inverse of b over a. Cool. Something you will need to watch out for, because we don't have any numbers in here, but just to say, assume we have, okay? We need to be thinking also about what quadrant this angle is going to fall in, okay? Because the way that graphs fit together, we'll go into this in more detail in a bit, the way that graphs fit together, you need to be really, really thoughtful. But since these are both positive, we draw a cast diagram here. If these are both positive, right, we know that it's going to fall. For cos, it's going to go there and there. For sine, it's going to go there and there. So both things are showing in the first quadrant, so we can say it's going to be in the first quadrant. Okay, that might seem a bit abstract now, but we'll go into it in more detail. Okay, so that leaves you with everything you want to know. So you've got your k and you've got your alpha, and that means you can finish up your equation with k cos x minus alpha. You get everything you need there using these expressions. Now, this does look a little messy, but we're going to do an example now and it'll become a lot clearer.